I'm making a little video to tell you why the fact that the block is moving or not moving or sliding or not sliding on the slope does not depend of the weight. Yes, ready. And how to prove that? Let's do some free body diagrams. So we will use two axes, x and y, with x parallel to the slope and y perpendicular to the slope. We will draw the forces that we know. Oops, usually the weight. Like to do them in blue. Oops, so we have the weight. And usually there's two forces that we don't know. The normal force, perpendicular to the slope, and the friction force, parallel to the slope, in the opposite direction of the motion or not motion. I say motion or not motion because if there is no motion, we stay in statics. If there is some motion, we go in dynamics. But let's find the condition for staying in static. So if we look at these forces with the y, we have the axis theta there, the angle theta there, so we have the angle theta there. So let's draw the equation. On x, oops, on x, what do we have? We have minus the force of friction. And for the weight, that will be the complement on the opposite side, so sine, so plus W sine theta equals 0. So we can write W sine theta equal the force of friction. Okay? Oops, the force of friction. If it's not moving, it's equal to 0. If it's moving, we will have an acceleration in that direction, so we will have minus FFF plus W sine theta that is more than 0. So we will have W sine theta that is more than the force of friction. The force of friction cannot balance the weight times sine theta anymore. Okay. Let's now look at the y-axis. On the y-axis, we have the normal force going up, and we have W going down, and that will be now the y complement, so that will be with the cosine. So minus W cosine theta equals 0. This one is always 0. If it's moving on the axis, not on the y. So we have W cosine theta that is equal minus minus plus n. So we have those two conditions. So let's see. We have W sine theta that is more than the force of friction, and W cosine theta that is equal to n. And this one is always, always, always true. Okay? Look at this. If we want to, let me use this one and I show you this one together. With those two conditions, what we can write that W sine theta equal the force of friction, and I divide by the both complement of the second equation, W cosine theta divided by n. And we can simplify this equation by sine theta divided by cosine theta equal the force of friction divided by n. So tangent theta equal the force of friction divided by n. Okay? And this is super convenient because what is the force of friction? We know that the force of friction equals mu s times n. So we will replace FF by the mu s times n. So we can write that tangent theta equal mu s n divided by n. So tangent theta equal mu s. And that's how we find the mu, okay? There's a little experimentation to find that. But if we come back on this one, okay, to have W sine theta superior of FF, the force of friction, at the end, that means that we need tangent theta superior at mu s. And this one then will make it move. So let's come back on that. When the weight sine theta is more than the force of friction, the block is moving. So when tangent theta is more than mu s, the block is moving. So does that depend of the weight? No. No more weight. No more weight in that equation. The only thing is like the slope theta, like this. The more we increase it, because the tangent theta increase with the angle, the larger must be mu s to balance the angle of the slope and to not moving. So what we prove is that to not move, we need tangent theta lower than mu s, and to move, that will move when tangent theta is more than mu s. That not depends on the weight. This is just my little video. So in your conclusion, when you say that the force of friction must balance the weight component on the x-axis, that's true. So if W sine theta is more than the force of friction, it's moving. But if we look a little bit deeper at what is force of friction, using the equation on y with the normal force, what we can conclude is like tangent theta, we can go like a few steps after that, and that will mean that tangent theta is superior mu s for the block to move. We can delete the weight. So that's it, just to show you that the fact that the block is moving on a slope does not depend on the mass of the block or the weight of the block. It just depends of the slope and the coefficient of friction. And this coefficient of friction depends on what? The surface in contact. Okay? If it's smooth, if it's rough, if it's a large area, that just depends on that. Here we go. Hope you enjoy. Bye-bye.